Alright, we're back here looking at radicals and specifically adding and subtracting radicals. This video might be a little bit longer, so if you feel comfortable with these first couple, then you're more than welcome to look at the last couple problems that I do, because those are going to be a little more in detail. But specifically when you're adding and subtracting radicals, like you look at this problem right here, if we add these radicals together, when you add radicals, the radicand, or the number inside the radical, has to be the same. So like here, notice radical 3, radical 3. These radicals have the same thing inside them. So what you do is, your answer is going to be radical 3, but what you add is you add the outside numbers, the coefficients. So the number outside of this radical is a 1, and the number outside of this radical is a 1. So 1 plus 1 equals 2. And that would be the answer for that one. So again, the radicands, if they're the same, you keep it the same in the answer, and you add or combine the coefficients, the numbers on the outside. So I'm not going to do number 2, but I'll take a look at number 3 and probably number 4. Notice here our radicals are the same. So radical 2, that's excellent. We know it's going to be radical 2. And then, so we just combine the outside. So negative 2 plus 2, well, negative 2 plus 2 is 0. Well, we can't have 0 radical 2. What's going on there is they're being multiplied. So 0 times anything, the final answer is going to be 0. So this one right here, the final answer would be 0. Negative 2 plus 2 is 0. And 0 times that is going to be 0. Okay? Let's take a look at number 4. Notice our radicals are the same. That's excellent. So it's radical 2. Notice we have a negative out here in front. So what is the number with that negative? Well, when there's no number, you put a 1. Minus, what's the number out in front of here? Well, that's 1. So what's negative 1 minus 1? And this is something a lot of students usually get confused with. They think it's 0, but actually negative 1 minus 1 would be negative 2. And that would be the final answer. Negative 1 minus 1. And you think about on a number line, right? 0, negative 1, negative 2, 1, and 2, right? Anytime you add a number, you always move to the right. When you subtract a number, you move to the left. So that's essentially what's happening here. We start at negative 1, because it says negative 1. We start there. And then we're minusing 1, subtracting 1. So when we subtract, we move to the left. So that gets us to negative 2. That's why that is negative 2, just based on a number line. Remember, when we add, we move to the right. When we subtract, we move to the left. So that's why it's negative 2. All right, let's jump into some questions that are a little more difficult. I'm going to do probably number 5, 6, and I might do number 8. All of these are really good problems. This is a great problem to start out with, though, with number 5. So notice the radicands, or the radicals here, are not the same. I've got 8 and I've got 2. So I can't combine them. But what I can do is try to make one of these, these numbers be the same thing. So this is 2, this is 8. 2 can't be broken down, but 8 can. So let's go ahead and break 8 down, and hopefully we get, there we go, I have the fuzzies. We've got 4 times 2, that's how you get 8. Well, 2 is a prime number, so you circle that. Again, go back to watch my breaking down radicals video in order to do what I'm doing right now. So we've got 2, 2, and 2. So I'm going to put that all inside the radical. 2, 2, and 2. Notice I still have that number on the outside, the Uber driver, right? That's what we called that. That Uber driver is going to come down here. Okay? Now, do I have any pairs inside the radical? I do. That comes out. So that pair of 2's comes out to be just 1, 2. All right, that pair of 2's comes out to be just 1, 2. All right, so now, well, what do we have out here? We have negative 2 times 2, which is negative 4. What's left inside the radical is that 2, so it's negative 4 radical 2. So this right here, this negative 2 radical 8 became negative 4 radical 2 based on all the work that we just did. Pulled it out, got that, the pair of 2's came out to be 2, we multiply it by negative 2 to get negative 4, and the 2 was left inside the radical. Now, have we done anything with this? And the answer to that would be no. So we're going to bring that down here with the problem. Now, take a look at the problem. Are our radicals the same? And that would be yes. Radical 2, they are the same. So our final answer is going to have a radical 2, just based on they both have radicals. What's negative 4 plus 2? Well, negative 4 plus 2 equals negative 2. And that would be our final answer. Negative 2, radical 2. That is our final answer for that one. Okay? Let's take a look at number 6. I think number 6 is a great question. Notice our radicals are not the same here. So we can't break 3 down, but we can break 12 down. And that is, 2 times 6, 2 is prime, 2 times 3, 2 and 3 are both prime. So now, again, following the same steps, 2, 2, and 3. But notice we have that negative out there. That negative is your Uber driver. What is that number with the negative? It's a 1. So we're going to bring it all the way down here. So that's negative 1 times. And then do we have any pairs? Absolutely. We have a pair of 2's right here. That comes out to be a 2. So notice, what is negative 1 times 2? Right, that's negative 2. What's left inside the radical is the 3, so we put the 3. All right. Again, just go back and listen, and if you didn't understand that, rewind the video and go back and watch that again to hear the recap. But now we still have this to deal with, the minus 2 radical 3. Minus 2 radical 3. We need to bring that down over here. So that's what we're going to do. We're going to put minus 2 radical 3. Okay, we just brought that down over here. So it was there. We want to put it there. So now our radicals are the same now. So we know it's going to be radical 3. And we just combine our coefficients. What's negative 2 minus 2? And that answer would be negative 4. Negative 4, radical 3. Negative 4, radical 3. Okay? All right, now I'm going to do the last one here. This will be the last one for the video. If you need me to do any more, please shoot me a comment or ask me in class to do a couple. I might review the quiz that we just took. I actually do the entire quiz for a video, but we will find out. So 6 and 54, notice they are not the same. 6 breaks down to 2 times 3, but there's no pairs, so 6 actually doesn't break down, but 54 does. 54, that is what, 8 times 6, times 6, and then we have here, we've got 2 and 4, 2 and 3, 2 is prime, 2 is prime, 3 is prime, the 4 is 2 and 2. So I've got all my prime numbers circled. Okay, just broke it down. I'm going to write them all inside the radical. So we have a 2, a 2, a 2, a 2, and a 3. Okay. Now, again, we still have that 3 on the outside, so we need to bring that 3. It's a positive 3 because it's a plus. Bring that 3 over here. Do I have any pairs? Well, I've got a pair of 2's. A pair of 2's. They're going to come out. They're going to come out. So I've got this 3 already on the outside. This pair of 2's comes out to be 1, 2. This pair of 2's comes out to be 1, 2. So I've got 3 times 2 times 2. Well, 3 times 2 is 6. 6 times 2 is 12. So I've got 12 on the outside. What's left on the inside is the 3. So I've got 12 radical 3. So I'm going to write that down. 12 radical 3. Now that was just this part right here. We still need to take in consideration the negative 3 radical 6. So let's do that. Negative 3 radical 6. And it looks like we ran across some kind of mistake here. Some kind of mistake happened. So essentially need to find the mistake here. Need to find the mistake here. So let's see if we did this right or wrong. And this is good. This is great for, I think, the students to see as well. just if you use the wrong, essentially if you use the wrong number, you can see how the entire question goes awry. So again, what I found out here was that I used the wrong number here. Instead of 7, I used 6. So this is where I messed up. I messed up this part right here. I did 8 times 6 when really it should have been 8 times 7. So that means I got to really do this whole problem over again. So let's go back and do the whole problem over again. Coach D with the mess up. Alright, so let's go back here. Fresh piece of paper. I would just make sure you just use another scratch sheet of paper if you didn't have another one in front of you. So 54, I'm going to break that down. That's going to be 8 times 7. Okay, 8 times 7 is going to be 54. No, it's not. No, see, I almost messed up again. That would be 54 would be 9 times 6 over here. 54, 9 times 6. There we go. All right. Finally getting back on track. So 9 breaks down to 3 and 3, and 6 breaks down to 2 and 3. 3, 2, 3. So we have all of our prime numbers. 2, 3, 3, and 3. So now we're going to circle our, well, first off we need to bring down the Uber driver down here. And then we have a pair of 3s we're going to bring out. So our Uber driver is a 3, and our pair of 3s becomes a 3. So 3 times 3 gives us 9. And then what do we have left inside the radical? We have a 2 and a 3. A 2 and a 3. Well, what's 2 times 3? 6. 2 times 3 is 6. So this whole work, or this right here, 3 radical 54, ended up becoming 9 radical 6. So now I need to bring this down, the negative 3 radical 6. And notice there's no sign here with the 9, but we know the 9 is positive, so we're going to put a plus. So now look, our radicals are the same, so that's radical 6. And then we have negative 3 plus 9. Negative 3 plus 9 is going to be 6. So the final answer here would be 6 radical 6. All right, thank you all for watching. Again, sorry about the mistake on number 8. I'm glad you got to see that though, because sometimes again mistakes do happen. And notice when we picked up on the one we just did that I made the mistake. Notice I made the mistake. I had 6 and 3. 6 and 3 as my radicals. And that's where I knew the mistake was had, because it should come out to be both of the radicals are the same. When I saw that both the radicals were not the same, I was like, wait, I must have made a mistake. So I went all the way back to the beginning. 8 times 6. Well, wait a second. That's not right. That gives me 48. That doesn't give me 54. So I went back and changed the 8 to a 9, and we just redid the whole problem. And notice when we got to this step, we had 6's on both radicals, and that's when you know you did the right thing. And our final answer there was 6 radical 6. Thank you all for watching. Again, comment, like, subscribe, put on notifications so that you can see all the latest videos that I post to help you out in Algebra 1. Have a good weekend.